There's two types of circuits that I want my students to know about. And when you are thinking about Ohm's law and you're trying to understand basics about electronics, these types of circuits can be found in all kinds of different things. Once you know the basic pattern, you can start to recognize them in whatever you're looking at. So when you crack open that black box and you take a look at it, you try and map out where the energy is flowing, maybe you can see what kind of circuit you're actually looking at. So here are the two types of circuits that I want you to know about. We have a series circuit, and we have a parallel circuit. Both of these start with some kind of voltage source. V. And this is where they start to differ. A series circuit comes down here, and now let's take a series of resistors, and we're going to connect them end to end like this, and then come back up through here. So we have R1, R2, and R3. And what we find in this circuit is that the current, when it's going from one side of the voltage source to the other, every time it crosses a resistor, it slows down. It's impeded more and more and more. And so the current here is going to be less, or it's going to be less, here's where you're going to get your first initial reading of current. The current here is going to be less than it was here. And the current here is going to be less than it was here. And that's because these resistors are additive. They're adding together and impeding the currents. So the total resistance of the circuit is going to give you I here. Now on the other side, parallel circuits start like here. We have our three resistors, and they're connected like this. So something interesting happens here. Here's R1, R2, and R3. The current across each resistor, because it's splitting, boom, 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 the current across each resistor is the same. It doesn't drop at all. However, because the current is splitting, the amount of electrons is splitting between each resistor, the voltage across each resistor drops, depending on the amount of resistors that you add. Okay, so there's less potential. When it has to go through three resistors at the same time, there's less potential electrons going through each resistor at the same time. Whereas in this circuit here, in a series circuit, all of the electrons are eventually going to go through all three resistors. Okay, this one here has its advantages. This one here has its advantages. For example, this one here will deliver all of the electrons all the way through each one of these resistors. And so if they need to have, they need to have a certain amount of voltage in order to run, there's no voltage drop here. And there's no current drop here. Okay, so each one of these could be appliances, for example, and if they need the same kind of current in order to run, each of these resistors is going to receive the same amount of current from that voltage source. Now another advantage of this kind of circuit is that if you take this resistor out, or if it burns out, or something happens, these two are going to keep running. Whereas if this one burns out here, and electrons are no longer able to go through the whole circuit crashes, and it no longer works. So there's lots of advantages and disadvantages for series and parallel circuits, and electricians use this basic pattern when they are doing anything, from wiring up your black boxes to wiring up your house or whatever. Look for them when you open up an appliance and see what you can see.